Hello, my name is Mustafa Alperen and this is going to be my Lab 1 charge tape for Physics 2212. So here's just a quick table of contents. First off, I'll just be going over the introduction, some conditions and details of the lab, the questions for the experiment, the coding process, as well as answering the questions what if or what does it mean. So the purpose of our lab is to simulate the interaction between two charged pieces of tape in an experiment and in GlowScript to be able to predict the number of electrons we took away from the tape. Our physics fundamental principles are just Newton's second law, which is a force of an object equals the rate of change of its momentum, commonly referred to as F net equals ma, as well as Coulomb's law, which is the force between charges proportional to their charges and their distance, commonly known as Fe, force of the electric field, is equal to k q1 q2 over r squared. And thirdly, the preview or main result, two charged pieces of tape repelled each other both in real life and in the simulated coding environment of GlowScript. They were both very similar. So the conditions and details of our lab. In our system and surroundings, the system was the top and the bottom pieces of tape, while the surrounding was everything else. Set up the experiment, we had to rip a tape off another tape from the table, then levitate the charge tape off of the table in such a manner that it didn't touch the ground, and we had enough space to put the other piece of charge tape under it. And then we just do that and then measure how much they repelled each other. Our initial conditions were that the tape length is 20 centimeters, tape width is 1 centimeter, and the separation distance is 0.254 meters or 2.54 centimeters. And we had to assume a point charge model for the tape in GlowScript. We also had to assume that electrons were evenly distributed among the tape, like they weren't more on the left side than on the right side, etc. So some questions for our experiment. What's the length of our piece of paper, our tape? It was 20 centimeters. What's the mass of one piece of tape? Our estimated calculations put it around 2.2 times 10 to the negative 4 kilos. The distance between our tapes was again 2.54 centimeters. The magnitude of gravitational force of the floating tape was calculated using F equals mg, which gave around 0.001962 newtons, and our electric force had to be the same as this because there was no acceleration on the tape, but we could also calculate it using Coulomb's law of k q1 q2 over r squared times r hat, which also gave us, again, the same thing. So here's our code. Uh, in the beginning section of the code right here, you can see I just sort of went along and defined some of the initial variables. I went along to make the sphere for the top and bottom pieces of tape, the bottom being blue, the top being red, and the force of gravitational was calculated. The arrow for that was color orange. Then just the charge, etc., etc., going along, defining the electric field as tape R mag and R hat. Then using that defined function, find the electric field from the bottom and the top, and those are going to equal each other. And the magnitude of one charge of tape came out in this scenario to be 1.1859 times 10 to the negative 8. Some possible errors in my lab was that the electrons could have not been evenly distributed among the tape, and the charges from other objects near it could have affected the net electric field, although slightly. Some similarities and differences was that the simulation was successfully able to model this experiment, and like the outside factors didn't cause a big enough effect on the closeness electric field, the net electric field from the two pieces of tape. There was a slight difference, of course, between the simulation and the real life actual measurement. And I think that's just because of, again, the outside electric forces causing a change in the net electric force. So what if, or what does it mean? What if the electrons had a positive charge and the protons had a negative charge? Would anything change about our observations? No, nothing would change as the tapes would still repel each other, as the main reason they repel each other is because they have the same charge. If the positives and negatives were changed, they would still have the same charge. So they would still repel each other. And what does it mean? Is it important to handle the charge tapes as little as possible? What happens when they come into contact with your hands or another object? The touching charges would try to balance out if it came into contact with anything else. So for example, if it came into contact with my hand, the electrons would shift from one to another, try to balance out. So this would lessen the repelling force between the two pieces of tape, causing a lowering of the force. Thank you all for listening.